Hello, everyone. Welcome to the talk How HelloFresh Leverages Feature Engineering and Modeling Techniques to Inform Menu Design by Delina. I would like to welcome Delina and thank her for doing the talk today. I am Jalpa, your moderator for the talk. I am a master's student at the University of Windsor, researching in AI and NLP. A brief introduction about Delina. She has over 10 years of experience in data analytics over a variety of domains, including financial services, CPG, and functions, which includes product management, operations, and marketing. She currently leads a full service data team at HelloFresh Canada, supporting all business functions with engineering, reporting, and modeling needs to improve decision making in revenue growth and cost management. At any point during the presentation, if you have questions, please feel free to post them in the chat. And I would now hand over the virtual mic to Delina. Thank you again, Delina.
Awesome. Thanks so much for having me. Hi, everybody. It's nice to see some friendly faces in the audience. So I will share my screen and we can get started. I'm really excited to be here because we are doing some really cool stuff at HelloFresh, and I'm excited to talk about what we're doing because it is a really complex business. So as Japal mentioned, a really quick background on myself. I currently lead a data team at HelloFresh Canada. HelloFresh operates in about 16 countries all over the world. So our team here locally supports all business units. So we support revenue, cost management, which includes product marketing, production, procurement, any sort of operations, HR, finance, etc. So we really get the full view of the business, and it's hard not to do that when you are an on-demand business. Prior to this, I did spend about 10 years across consulting, banking, various roles in analytics. So this is a little bit about myself. But to start off, I'm going to talk a little bit about what HelloFresh is, and maybe a question to the audience. Has anybody here tried HelloFresh before? Has anybody heard of the company? And if you have, feel free to post in the chat. I will ask you a couple of questions throughout the session. Awesome. So HelloFresh is a food solutions company. That's how we like to describe ourselves. Our objective is to minimize food waste. So the way that the company works, if you haven't tried it before, customers are able to select from about 50 recipes online every single week. So they can do so either through our app or through our website. They can pick what they want. We have a variety of recipe preferences. So for example, like meat and potatoes, vegetarian, and so on and so forth. So customers can select any one of about 50 or 3 to 4 of about 50 recipes for either a 2-person box or a 4-person box. Then we will order the ingredients from our suppliers. We'll pack all of the ingredients nicely in a box, and then we'll ship that box to customers' doorstep where they will then cook their meals. So my first question for you is, what do you think makes this business challenging? Why is this such a difficult business to work in? And because we're at a machine learning conference, feel free to tell me your thoughts on the data challenges. Yeah, so managing food availability is one, so supply chain. What else? Yep, forecasting, logistics, absolutely logistics. So trying to figure out what to deliver, how to optimize our logistics process. And then Celine, to your point, we may not know what customers will order or any new trends. Data drift due to seasonality, absolutely. All very, very big questions and very difficult things to solve. So I like to bucket our challenges in 2 kind of areas. So if we think about the business, we have a revenue generating component, which is the product itself. And we also have a cost component, which is our operation. Unfortunately, we cannot look at one without looking at the other, because every single time we make a change to our product, that has really big implications to our operations. For example, right now we run about 50 recipes a week, which includes regular sort of meal recipes and also some add-ons and other kind of add-on items, grocery items, things like that. And so every single time we add an additional recipe, we have to think about how we can manipulate our production to meet that additional operational constraint. And of course, if you've ever worked in manufacturing, there's a million constraints that exist in manufacturing, but size and capacity is one of the big constraints there. So from a product side and a revenue generation side, the top business challenges that we face are, number one, it's difficult to forecast what customers will select because customers have a lot of choice. And out of 50 recipes, if people are only ordering 3 or 4, then that means we're not going to have the same recipes across every customer. Everybody's going to select slightly different combinations of recipes. Our turnaround time between when a customer finalizes their order and when they receive their box is 4 days. So forecasting for us is really important, because if we're not able to forecast accurately, we won't be able to order the right amount from our suppliers. And for those of you who live in Canada, you know that Canada is a very big country. And so whenever we order things from suppliers, sometimes there's long lead times, sometimes we're buying stuff from very far away. And so we need to be able to know in advance what we think people will order so that we can have a sufficient supply. The second sort of constraint in the revenue side is the ensuring that the menu actually meets all personal preferences. So I would love if everybody liked the same thing, and if we would be able to say that all people tend to like pasta and salad, and so those are the types of recipes that we have, and therefore it's really easy to forecast. That would be ideal. But in a country as big as Canada, we tend to have very different preferences on the East Coast versus West Coast, in urban areas versus rural areas. And so depending on where our customers are situated, that poses another challenge, because we need to have enough variety in the menu that people are not turned off. And we need to manage that variety in a way that we're also able to predict what people will get, so that we can then manage our supply chain and operations. On the cost side, the complexity here really is, again, that short time frame between when an order is finalized and when a delivery should be delivered to the customer. And so in here, we typically deal with short supplier lead times or long supplier lead times, production and capacity management within our production facilities. And then, as you guys said, logistics. Logistics is also a challenge, because we're dealing with a perishable food item. We don't have the luxury of something that has a long shelf life. And so as soon as a box is ready, it needs to be out of the door, and it needs to be going to wherever customers live. And so again, if we're kind of delivering something from Ontario to the East Coast, then we get a bunch of other complex questions around how do we keep it cold? How do we make sure that it doesn't get ruined on the way? So those are kind of the two challenges that we typically deal with. Now, today's presentation will focus largely on challenge number 1, because this is the main question, right? How do we know what customers want, and how do we build a menu in a way that they will be satisfied? And then the better we get at predicting what customers want, the better we will be at managing our operation, because again, everything starts with forecasting. So as a company, for those of you that have studied sociology in the past, or any sort of mass group psychology, it is pretty difficult to understand preferences if you are not yet a big company with a massive customer base. When people are organized in large groups, they tend to kind of come towards an average, or some sort of mean behavior, right? An average behavior. We are still, while we're growing, we're still not at the size of a customer base where we tend to have consistent behavior in our customers. And so if we were a really big company, we would be able to say that most customers want X, Y, Z. And then there's these other smaller periphery groups of customers who want something a little bit different. And so the business starts to become more predictable. For us, we are still small enough that we have quite a bit of variability in what people want. And so some people are going to want salad, some people want soup, some people want pasta. And so what we've focused on over the last few months is how do we get a better understanding of not only what do people want, but how do we build depth in our relationships so that people continue to like our product on a week-to-week basis, and so that they continue to order from us, because again, we are a subscription-based service. For subscription-based services, there is kind of 2 challenges in this business where it's really easy to acquire people, because typically all you have to do is offer a discount, or you offer some free boxes. And so it's easy to get people to try your product. What is difficult is getting people to consistently order your product. So you need to have some sort of value that you're delivering to the customer. And so for us, the question becomes, what is the value that we are delivering to the customer, and what are people looking for? So how can we learn about what our customers want? There are a few key sets of data points that are available to us through the data that we collect. We don't collect a whole lot of personal data because we are a food company, and so privacy regulations restrict us from collecting very personal and demographic information. However, we have a lot of valuable information in other formats. We collect feedback regularly from our customers through 2 different channels. One is through surveys about the service overall, and the other one is through weekly recipe feedback, where we understand what they like and don't like. We also have purchasing and ordering patterns, so we can see when somebody purchased a box last, how long it was between their last box and the box before that, what they selected in their box, which recipes they swapped out versus the one we pitched to them, and so on. We can see meal selection patterns. So if they tend to switch out, like every week we will show them 4 recipes that we suggest they buy. And some people will switch out of those recipes. Some people will keep them. And then we have digital engagement data, which is how they interact with our app, how they interact with our website, how they peruse through the menu, how they make decisions. And so if you've ever worked with any of these types of data, none of these are easy data points to work with because the information in them is so sort of deep, and the information is so convoluted that it takes a lot of time to kind of twist it in a way or format it in a way that's going to be useful to you. So the first sort of section I'll talk about is understanding preferences based on purchasing patterns. The first question that we have when we're trying to do customer analysis is, what is a good customer? What defines somebody that's a good customer? So again, in the subscription-based business, everybody kind of starts out as a low-value customer. And what I mean by that is that everybody is new, they're trying out your product, chances are they have a free trial or a free box, and so they're not really bringing in any revenue. The catch in this business is, how do we then take that customer and how do we convert them to a high value customer? And a high value customer is one that probably orders from you either every week or every other week, or in a given year, maybe they order 26 boxes. So that means they're getting a box from you every other week. In our business, this is much more difficult to do than other subscription-based businesses because we have a higher price point. So something that is like Netflix is cheap enough that for a lot of people, it doesn't make a huge difference. They can also share the subscription, it's unlimited. And so the value is clearly there and the price point is not as significant to somebody's wallet. But for us, people are paying, $80 to $100 a box per week. And so there's got to be a value proposition there. And we're also competing with grocery stores, which are quite a bit cheaper. So it's easy to acquire customers in our business. It's hard to retain them. And so that's what we need to focus on. So the first question we asked ourselves is, what are the paths to becoming a high value customer? And our team did an analysis, which is commonly referred to as a recency frequency monetary or RFM analysis. This isn't anything novel or new, but it works really well in our business because what we need to understand is, number one, how fresh are customers? So what is the last time that they purchased a box from us? How frequently do they purchase boxes from us? And how much money do they spend when they purchase boxes from us? The reason this is really interesting is because there's many different paths to high value. A customer who is high value is not necessarily someone that buys from you every single week or spends a lot of money. You could have somebody that buys from you every week, but they're using a discount code every week, and that makes them very frequent, but it does not make them very high value from a profitability perspective. And so this framework kind of gives us a way to assess value and to see what are the different ways that somebody can become a high value customer so that we can play on those needs and those sort of perspectives when we pitch our product to them. So we did an analysis. This is not real data, but basically we put a whole bunch of customers and we gave each of them a recency score, a frequency score, and a net revenue score. So we looked at how recently they ordered from us on a weekly basis. We looked at or daily basis. We looked at the frequency, how often they order from us, and then how much revenue we got from them in a period of time. And then we created some clusters, and these are pretty simple clusters for each of these scores. And then we can add these up to give an overall score. And then that gives us 4 categories to deal with. So 1 being 0 to 2 being a low value customer, 3 to 5 being a low to mid value customer, and 6 to 7 being a high to mid value customer, and then 8+ being classified as a high value customer. Once we have this information, the next thing that is very interesting to us is, what are the inflection points of the customer relationship, and when do customers switch from being low value to mid value to high value? And so what this chart represents is, after we've defined our clusters of relationship depth, we now can identify how long does somebody need to be a customer consistently with us based on one of these 3 criteria, to make the switch between being a low value customer to a medium value to a high value. And so what you're seeing here is that it takes about, from our analysis, it takes about 9 to 10 weeks for that conversion to happen between stages. And this is really valuable from both the marketing and product perspective, because the marketing question becomes, and the product question really becomes, how do we shorten that time? So if it currently takes us almost 3 months to convert a customer from being a low value, somebody who's just trying out our product, to becoming a product that people keep in their house, we need to know what are those drivers, and that becomes the next question. So the first question that we've answered is what makes a high value customer and what are the inflection points that they switch. Now, the next question then becomes what I just said. How do we make that transition faster? And what do people care about? What do they value? And how can we make sure that we're catching them earlier than that 9 to 10 week frame? So the next exercise that we did that was really interesting is using some of our comment data, so comment category data, to understand what people care about. So for those of you that have worked with clustering algorithms before, you will know that K-means clustering is a really popular unsupervised clustering algorithm. One of the downsides is that it only really works on continuous data, or works most effectively with continuous data. But what happens if you're dealing with a lot of categorical data? So for us, again, because we don't collect a lot of demographic data, we don't have access to information like people's incomes or something like that, we need to use the data that we do have available to try and determine what people like and what they care about in our product. So we found this somewhat new algorithm, or something that perhaps is not as popular, but it's called a K-modes clustering algorithm. And it helps us use all of our comment data. So we have a bunch of comments that we receive from customers. We categorize the things that customers talk about into buckets. So for example, customers might talk about flavor, they might talk about child friendliness, convenience, family fit, healthiness, quality, variety, etc. And then we can use a K-modes clustering analysis to basically bucket all of the different comments that we receive. We can do this over time, or we can do it for all of our customers of all time, so that we can identify the things that they care about. So in this example here, what we've identified is that we have 6 main categories of things that people care about when it comes to our product. Number 1 being flavor. A lot of our customers, they like to cook and they like to have really good meals. And so if I answered the question of why are they using our product, the answer becomes because they want to be able to cook at home. They want to be able to eat delicious food at home. Maybe they're bored of what they're eating in their regular schedule. Then we have another bucket of people, the dark blue square, which is customers who like our product because of convenience and family fit. So these are the people that want to eliminate menu planning. They want to eliminate grocery shopping. They want to simplify their life. And so they want, recipes that are filling, they're healthy, they fit in a 30-minute time frame, and they'll come straight to their door. Then we have a healthiness category, which is the red category. So this is around ingredient balance, making sure that you have sort of variety and healthiness in the recipes. Then we have a section around quality and experience. So the orange section is about the quality of the product, and people are paying a premium. So how do we make sure that they're receiving the right level of quality? Then we have another section sort of on variety and menu selection, meal choice, preferences. So this is around if people have specialty diets, a bunch of people will care about that. And then we have a final section on overall product appeal. So ease of using the app, the fact that we're tech savvy, and so on. So this gives us a lot of interesting insight, because now we've answered the question not only of what makes a good customer, but also what the customers care about. And so we can combine these two categories of people. We can combine these two categories so that we can create more complete customer profiles, and we can inform everything else that we have going on. For those of you that are not familiar with how K-modes clustering works, and I'll focus a little bit of time on it because it's something that's really powerful if you're in a business that deals with a lot of categorical data and you don't have a lot of continuous data at your disposal. But very simply, the way that it works is, let's say that you have 10 customers and they've each answered our survey and they've given us feedback, and these are the comment categories that the feedback falls into. What we'll first need to do is we create some kind of base cluster. So we pick 3 customers, we look at their profiles, and then we compare those customers, the rest of the customers, to the dissimilarities between those profiles. So for example, in the first one here, we have time complexity, flavor, child friendly. So person 1, obviously this is the exact match to this first cluster. Person 2 has time complexity and flavor. So 2 out of the 3 values match. The third one, however, does not. And so this is going to get a dissimilarity score of 1. So every time we have more items that don't match, that dissimilarity score is going to go up. So then we get some clusters which tell us what are the dissimilarity scores between each of the clusters that we've defined. And then from here, we can now group people together. So basically, the way that we decide which cluster to put a person in is we take the lowest dissimilarity score. So we pick the cluster which is most similar to that person's behavior or that person's response. And so here we have 3 clusters. So cluster 1, these first 2 people go in it. Then cluster 2, we've got 3, 4, 7, and 10. And cluster 3, or that's cluster 3. And then cluster 2, we have 5, 6, 8, and 9. So then what we do is we look at each cluster. So we put all of those people's information into one kind of big data set. And this is all happening in the background, obviously, but we put all this information in a big data set, and now we create new clusters based on the information by finding the most common value. So the descriptors of the first cluster become time complexity, flavor, and child friendliness. The second cluster, the descriptors in this example are variety, healthiness, and child friendliness. And the third cluster, the descriptors are delivery, ingredient quality, and app use. Okay. So that's a very good question, John. So it is not free-form. It is free-form feedback originally, and we actually have a third party that does some natural language processing for us. And so they create categories based on rules of the things that pop up in our comments. So they'll look at sentiment, and then they'll also look at what did the person specifically mention in the comment, and then that comment will get put into a defined category. So I think we have a list of about 40 different categories or so that people that we categorize comments in. And then what we're actually using is those categorizations. We're not using the free-form feedback. But if you do have free-form feedback, what you should do is create a sentiment analysis first. And it's probably like a supervised approach to defining what categories do I care about, put the comments in those categories. And then at this stage, you can use the K-modes clustering for those particular categories. Does that help? Cool. Okay, so finally, we have a bunch of clusters. And so that then brings us back to this chart, which then tells us what people care about. So now I know if I'm a product person, if I'm a marketing person, I know that most of my people care about flavor, but there's these other people that also care about the ease of the product. And so if I'm in culinary, I can now make a decision to say, okay, I obviously need to make recipes that are 30 minutes or less. Also, maybe I'll avoid using some salt so that I can add more flavor with other spices. And then the last point on this is that this will change over time. So this is a representative view of the last 5 years that HelloFresh has been in operation here in Canada. But of course, this will kind of change week to week. And so by doing this analysis, we also have the ability to monitor how that changes week to week, and we can identify trends like people caring more about flavor, caring less about flavor, and sort of the composition of our customer base. So what does this mean for recipe development? This means, in our case here, it means that we need to focus on time and convenience because our second biggest group of people buy this product because of convenience. And the second thing it means is that we need to focus on flavor. So in this case, we need to focus on flavor because, we can't just add salt to everything. And so we need to make sure that we have the right spices and the right flavor profiles to meet people's needs. And if we do want to know specifically about flavor, that's a little bit of a more difficult question because there's other complexities around people's palates. Some people like spicy, some people like salty, some people like sour flavors. And so I'll get to that in just a minute here. Okay, so that kind of covers how we understand our customers and what they want. And then the last quick piece that I wanted to talk about is then how do we design recipes and how do we design our menu based on that information? Because of course, flavor is a very broad term about what people care about, but again, specifically, it's going to be specific to each people. So, a broad question: if let's say you were working at HelloFresh and you knew that you knew the general performance of recipes, how would you use this knowledge to inform your menu? And I know that that's a very broad question, but what ideas do you have on how we would use prior recipe performance or product performance to design future recipes? Yeah, you could look at similarity scores. Absolutely. You could look at, you could look at the categories. Absolutely. So it's a difficult question because there's kind of two ways to look at this problem. We are always creating new recipes because we're always trying to exceed customer expectations. So there's kind of the hindsight view, which says we can look at previous recipe performance and we can say, okay, chicken and potatoes performs really well in Ontario, but fish performs better in BC. And so we have, 30% BC customers, and therefore we need to have a menu that comprises of 30% fish. But there's infinite amounts of fish recipes that we could put together. So when we're thinking about the menu, we could also look at the ingredients and use a simple regex and sort of explore how the different ingredients are operating, or how the different ingredients perform when they're comprised in a full recipe. So what is really powerful is that we want to use the information that we have in two different ways. One is to understand in hindsight what happened, and if we create a new recipe, how well do we think it will perform? The second question, though, is can we actually prescribe what recipes will do well? Can we tell our culinary team, if you create a recipe that has X, Y, Z in it, this recipe will perform really well. If you create a recipe that has X, Y, Z in it, it will not perform well. So combined with real-time ingredient pricing and customer pattern insight for optimized and novel recipes. Yes, Kelvin, that is the dream. That is the dream. One day, but that is a very big data exercise. So approach number one is that we can identify what makes a good recipe. So exactly to your guys' point, we can look at performance of past recipes and by customer cluster, and we can sort of decide people who care about flavor, what do they care about, what kind of recipes do they care about, and what do they like, what do they not like. Why is this approach problematic? What would this not help us do? I'll give you a quick hint. What if we introduce a new ingredient that we've never used before? Yeah. No training data, exactly. So if we use this approach, we won't actually be able to deal with any new ingredients, and we probably introduce maybe 5 to 10 new ingredients every month, or every quarter rather, not every month. So we have to kind of be able to predict what are those sort of ingredients going to perform, how are they going to perform. And Stephanie, to your point, a better approach is probably to somehow generalize. But generalizing is difficult because we could group things. Like we could say, okay, pastas is one group, rices is another group, tomatoes varieties are another group. We could generalize that way, but what else are we missing if we identify logical groups of ingredients? What else influences recipe performance? And think about your own experience. What makes you like or dislike a recipe besides just the ingredients? Yeah, time of prep, absolutely. Convenience, spiciness, how the ingredients are used, exactly. And so the reason that this is such a hard problem, vague instructions, though also problematic, but the reason this is such a hard problem is because it's really difficult to actually account for the subjectivity of taste, texture, smell, and personal palate, so those types of things. Also cuisine. So there's some tangible information that we do have about our recipes, which we can collect pretty easily. We can feed into a model, and then we can sort of predict how will this do. We can also generalize and kind of try to generalize as much as possible and then predict how things will do. But the things that are difficult to account for is the subjectivity. And Kelvin, exactly to your point, also, what do people have in the kitchen? It's really difficult to design a recipe that's common enough for everybody to build with the limited, perhaps, appliances or tools that they have, and also have enough variety that it's interesting. So what we're working on now, and this is a bit of forward looking, and then I'll pause for questions, but what we're working on now is we're trying to figure out what the best way is to create ingredient categories based on ingredient purpose rather than just regular sort of like aspect-based categorizations of things. And so we're trying to create ingredient categories, maybe things like flavor enhancers, staple ingredient versus non-staple ingredient, anything that's complementary, anything that creates a texture, or if we can even understand how to describe texture. So this is a really manual exercise because it requires not only a lot of recipe testing, but it also requires a lot of feedback from people and kind of figuring out what is the best way to organize that information so that it's going to be meaningful for a model. So lots of trial and error. The second piece that we need to kind of figure out is how do we capture recipe performance? Right now, customers will rate our recipes from 1 to 4. But when you have a very short scale of ratings, you probably will not get a lot of variety in your responses. And so what we see is that most people either answer 1 or 2, or they answer 3 or 4. The third piece around this is that we collect feedback weekly in our recipe feedback, but our other generalized surveys are done maybe once every few weeks. And so customers will tend to comment on things that have nothing to do with the actual recipe. They will comment on, their experience or something else that they like or dislike. From there, we can use a regressor, and we've tried this before to find drivers of recipe scores. This is probably the right thing to do on a mass level. And then our main objectives of this exercise is, number one, to build some sort of predictive models where our culinary team can actually manipulate it and play around with it and say, if I create this recipe that has this texture with these ingredients, how well is that likely to do? What we'd love to get to is at a regional level, so in different parts of Canada. And then the ultimate goal of automation is, we don't want to automate this because it is quite subjective, but how can we actually build a prescriptive model that can proactively suggest recipes? So as we see trends in what people are buying and what they're ordering, could we even predict or prescribe what upcoming recipes and menu composition should be, so that we can continue that trend and deepen that relationship? Okay, so I will wrap up there, and I will leave some time for questions. Jen, does it work to ask which chefs produce high performance novel recipe rather than focusing primarily on ingredients? Yes. There's probably some ethics associated with that, because the now we're getting into employee performance. But it is a good thought. It is worth it. And perhaps it's not even about them so much, but it's probably about the style in which they cook. And if we can kind of translate that to a data point, then that will certainly make it a good input variable. Find that recipes are similar across weeks. It seems like just switching out pork for beef. Yep. Is there anything being done to provide more variety? Yeah, and so that's another good question. So and this is the problem we're trying to solve. So we know that, I'll give you a quick example, but in some taste profiles in Canada, a lot of people that live in rural areas in Canada, they really like a meat and potatoes style dish, and that's all they order. And so we have to have a sufficient number of those recipes available, because a lot of our rural customers, they don't have access to a lot of services like this, or restaurants or other types of food providers. And so they really like when we bring in some variety, but they tend to kind of stick to the same structural food menu. People in Ontario tend to really like Mexican food. And so we always tend to have some rice and beef dishes and things like that, because we know it tends to be sort of popular. But then there's people like you that really like variety, and they want to try a whole bunch of different things. So the way that we're trying to, and the reason this is a difficult problem is because we have to kind of manage that in light of our operational complexity. If we don't have enough interest in something that is very different. And so every once in a while, we'll have these discovery recipes. I don't know if you've seen them on a menu, but usually they'll have kind of a new ingredient or something new that we're testing out. So to achieve that, like, that's where we kind of test what is the kind of uptake that we're likely to see. And then from there, we can kind of decide, like, is this something worth pursuing? Is it worth having that variety, or is there perhaps not enough volume for us to be able to justify that? Because every time we add a new recipe, we add probably about 10 additional minutes of complexity to our process in our production facility. It means more switchovers. It means more sort of optimization on the production side. So we still haven't figured out a good way to do that, or to make that switch over very quick, but we're working on it. I hope that answers your question. Question on deviation of recipe performance that's observed given demographics. Do they change that frequently? So recipe performance, we do have some sort of staple type of customers. So some customers really like, again, meat and potatoes and kind of that traditional view of a recipe. Some customers really like variety. Some customers really like, again, fish-based recipes or vegetarian-based recipes. So we do have some staples of customers. But because we're still quite new, and a lot of our customers are still comparing us to the traditional grocery store, and so really we're competing with that habit of people going to grocery stores, we still have quite a few new customers who are using the service for the variety. It's not something that's become kind of a staple in their life, where this is where they get their food solution from. So from our perspective, that still requires quite a bit of some method of ensuring that we have some level of variety. And we do still see quite a deviation between different groups and what they like and what they don't like. I would say that the deviation is typically geographical to some case, but also it's geographical in some case, but also it's based on like family size and things like that as well. What's the thought process we follow introducing new fields in surveys, which help build models? Very good question. Survey design is very difficult. Right now, we don't really design our own surveys. I think we're just getting to a stage now where we'll design our own surveys. And the reason for that is because when the company first started out, we decided to keep the surveys where we collect feedback. We decided to keep them quite simple because the more information we ask of people, the less likely they are to actually complete the survey. And so if you have something really simple that's free form, like give us a star rating rating 1 to 4, give us your feedback, more people are likely to give you information. And so when you're first starting out as a company, you want as much feedback as you can get, because that's what's going to help you build your product. Now that we're a little bit more mature, we'll probably have to, and so this is the question we're trying to answer, is should we be redefining how we collect data? Should we be redefining how we collect recipe feedback? And then from there, if we do, how do we have that inflection point of not asking too many questions to annoy people, but also asking enough to get sufficient information? Do we dollar cost optimize the outputs with machine learning? I'm assuming you mean optimizing things like logistics and production and things like that. Yes, we do have a number of optimization models that we use for production. We optimize our menu, so we do run our menu through an optimization model as well, which kind of finds the highest possible performing menu with the lowest possible cost. The way and so this stuff that we're trying to figure out is predicting how well recipes will perform on an individual basis so that we can more accurately produce an overall menu performance score. And that's going to help us then figure out what the trade-off is between cost and performance. We also optimize our production. So we have to produce multiple recipes on the same line. So sometimes if recipes share ingredients, we will put those recipes on the same line, but then the question becomes, when do you switch over and which recipes should you combine together for the fastest possible production? So those are some examples of how we optimize. In determining high value customers heuristically, is it heuristically designed with the 3 features you mentioned? Also, how might you classify potential growth of a customer? Yes, so heuristically designed, and so you could do it systemically. So you could also use clustering techniques to determine the performance of customers, so whether they're low, medium, or high value. Similar if you have that information. I think for our purpose, because we're kind of looking at just ranges of data points, it's pretty easy to identify those clusters. But if you have a more complex data structure, then I would use clustering to define the value of customers. And in terms of potential growth, that's a tricky one. So potential growth can be looked at from a few perspectives in a depth of relationship, that lens. Most notably, it's probably from a revenue and profitability perspective. And so there's some interesting things. So our US team, they actually did an analysis on emails, and they were able to predict potential profitability based on people's emails. And I'm assuming it's quite simple. I haven't actually looked into it, but I'm assuming it's quite simple because you can tell if somebody's signing up with a fake email or a real email. And if they're signing up with a real email, they're more likely to have a longer relationship with you as a company. But it's a tricky one because there's many different factors that contribute to growth and what people's profitability will be. We do have a famous model, not famous, but it's publicly available, the documentation. It's called Morpheus, and that's one of the ways that we predict future or customer lifetime value. It's one of the ways that we try to predict how profitable somebody will be at a customer level. And then from there, we can use that information to market to them. So if you Google Morpheus on Medium, you should be able to find the article there. Have you tried 2 recipe types for customers, one created by a chef and another by this process, then check which is preferred? Yeah, so that will be one way that we test it. So we haven't actually built a prescriptive model yet. We would like to do a prescriptive model to say, here's a suggestion on recipes. And that would be the way to test that. So we would, and that will kind of answer the question of like, is this something that can be automated? My initial hunch is that no, because there needs to be a people element to cooking and to art. But if we do build something like this, then yeah, it will be, that's one of the ways that we would test it. Okay. What's the basis of which features selected when building models or metrics used for feature selection? Good question. So right now we've tried a few different things. So we found that if we look at feature selection, if we look at just ingredient level, and we've looked at just ingredient level, we can use a few different types of models. Will have different attributes that can tell us which features perform the best. And so when we've tested that, that's one way that we can do it. However, I think this is really a feature engineering exercise because we need to kind of combine as much data as possible in as little dimensions as possible so that it'll work. And so it's a difficult question. We haven't quite answered on which features are most important, but normally we would look at either if certain models that we use, if we use a classification model, if they have a feature selection attribute as feature performance attribute, we can use that. You can also use other modeling techniques to identify them. Are you able to account for missing ingredients in the box affecting recipe ratings? Yes, and Stephanie, that's a really good point as well, because the a lot of times people will comment on other issues that have nothing to do with the recipe itself. We do our best through our NLP work that we have. We do our best to sort of take those out of the comments so that we can focus on just the comments that are related to the recipe. But there is going to be some we can't take that out of the rating. So if somebody gave like a 1 out of 4 and we're using that as our end output of the thing we're trying to predict, then it's really difficult to take that out of the rating itself. We can remove the comment, but we can't remove that out of the rating. So we probably need some multiplier or something to account for the fact that people will comment on those things. And I think I'll do one more question because I do have to go to another touch point. 2 more questions here. So how much liberty does the model get into prediction? For example, customers prefer more cheese and carbs as opposed to other items. Would that model recommend having that more? That's another good question. So it's, again, hard to capture sort of structure of a recipe because what is more carbs? What is more cheese? Like, is it a weight-based amount? Could you say, for example, and could you create a feature? And maybe we create a feature that says, what is the composition of this recipe? Carb heavy, dairy heavy, protein heavy. And then we'd have to define what that means because we have weights of all of our ingredients. So we could potentially use that to define what that means. But yeah, to your point, it could become a predictor. And I can't tell you right now if it's significant on recipe performance, but there are certainly people that do care about that. Feedback we often get, especially from people who have very physical jobs like construction workers, is always around portion size. And this isn't enough, which makes sense because they work all day, even though our portions are probably about anywhere from 800 to 1,000 calories a portion. So they are normal size portions. But we probably do need some sort of preference that is like somebody that works a lot physically. And Sam, to your question, what is our data engineering stack? We do use Spark, so we do use Databricks. That's probably the main kind of tool that we use, and we're actually just starting up our data engineering function, and so we do use a few. Databricks is probably the main one that we're using right now and that we're onboarding on. Actually, Alex Preciado from my team, he's our head of data engineering on our team, so he can probably give a little bit more context on what the vision is for that. But we are trying to get a bit more advanced with what access to tools so that we can do more. And I will say that it's been difficult because the company grew so much during COVID that we just did not have the time to adopt a lot of these technologies. But if you reach out to myself or you reach out to Alex, I will forward your inquiry to him, and I'm sure he'll be happy to talk to you about it. There we go. Thank you, Alex. All right. Okay, so I think we'll wrap up.
Thank you, Delina, for your presentation. It was a very engaging presentation and it was insightful. I know you have to leave now, so thank you everyone for joining us too. Have a great day.
Thank you guys so much. Have a great day. Bye-bye.
Bye, Delina.